Hello, I would like to do a quick video on tick and optimization in games. I feel like there are some underlying points to it that are a bit misunderstood, and I think I have a good demonstration and what I think is commonly the real problem with tick. So let's start off by talking about what tick is. Now, if you opened a blueprint, you will probably know tick as, I've got a Canon blueprint here, but we have event tick. Now, the important thing about event tick is, and it makes it a little different to everything else, is that it runs on every frame of the game by default. Now, tick isn't turned on by default. If I was to create an entirely new blueprint, it would, so I'll create a new blueprint here. You would have tick, but it would be grayed out. And that means it's not active at the moment. This node is disabled and will not be called until it becomes no longer grayed out. So if you're not using tick, that's great. It's going to do nothing. But it ticks on every frame of the game. Therefore, if you put code on this, it will run every single frame of the game. And if you're aiming for 60 frames a second, it will run 60 times a second. So it is right to be aware of it. If you put a lot of code onto it, it's heavy code, you may find that it slows down your game. However, often people get a bit hypersensitive about tick and they don't really use it in a good way because you'd be amazed how much you can get away with. And also how much stuff under the hood actually runs on tick. So it's not like this is something that just shouldn't be used. It's a great tool. So let's have a look to start with. So in the level, I have created a lot of cannons. Now these are a very, very simple blueprint. What these blueprints are if we have a look at the viewport, we have a couple of primitive meshes, and I'm just rotating them to face the camera. I'm going to do this in a couple of different ways. But at the moment, if I was to play and go full screen, there's a couple of things. Frames per second at the moment, we are hitting, we're averaging around 60. And that's fine. And we're not going to see a massive move, even though we've got hundreds of them, loads of these things. Now, if you'd look, we have a frame is costing, if you look at stat units in the top right-hand corner, the frame is taking 18 milliseconds. And the game, that's the CPU, and that is what tick runs on. That is only running at 11-ish milliseconds. The GPU time is running at 17 milliseconds. So the first thing that I can say here is the game thread, the CPU, has to wait for the GPU thread to finish. So the GPU is going to be our bottleneck. So in most cases, in this case, I have 6-ish seconds of CPU time going wanting. There's nothing happening. Therefore, we should be able to use that without seeing any impact on the game at all. Now, if you look as I move around, you can see that we have these things are moving towards us. Now, they're moving towards us slowly. I am not using tick at the moment. I want to show you what code I'm using because I've seen this done in other places. And I think a Canon is a good demonstration. Now, what I have here is I have a function here, which is to rotate to the camera. It is taking this pivot point and it is rotating it, set the world rotation, using a lerp to make it a bit smoother so that the camera manager is, so it's looking at the camera. Very simple, straightforward. Now this is being run on begin play. Now what you'll notice is, and this is something I've seen, is they're running the event, they're then delaying for 0.5 of a second, and they're running the event again. Now, if we watch this, you will see that they're moving slowly. So it's not necessarily ideal. Now, it's very visual in this case, but if it isn't as important, the visuality, that might be fine for you. And we are running at about 50 to 60 frames per second. But what you will notice is we keep popping down to around 40. And we're doing that twice a second. And that's because they are all ticking at exactly the same. They're all updating their movement on exactly the same frame. So that's not an ideal way. Now, I could come in, and a good way to fix that, the problem here is everything is on begin play. So if I wanted to fix that, what I would usually do is I would bung a delay before kicking this off. But for the duration, I would get a random float in range. And then I'd go 0 to 1. So all this is going to do is, the problem was at 0.5 of a second, all of the actors were going at exactly the same time. So even though it's a minute amount, it would make a jittery game. This is going to smooth it over a period of time. So I'll just compile again. We go in and run. You'll see that they're all moving slightly differently, but we shouldn't ever drop down to that 40. So we've got loads of these that are running, and they are, that's working absolutely fine. But the only problem with it is it's jerky. That's not how I would like it to work. So let's look at tick. Our tick that we are not supposed to use. So I'm going to drag out the tick here, plug it in. I'm going to use a slightly different code, but it basically does the same thing. I'm going to plug that into the world rotation, and I'm using an R-interp2 so that it's moving smoothly, rather than if the tick goes up and down, the movement would be unsmooth. So I'm doing exactly the same thing, updating the rotation. And I'm coming in here, and then I can press play. And now you'll see that all the cannons are going to move very, very smoothly towards me. Okay, that's nice. However, our frames per second have gone down. Well, they're varying between, but at some points you can see that they go down to 30 frames per second. And you'll see that our game thread is what is causing this. Now, there is a reason why I've created lots of these, because that is so that we can see that it is affecting the time. We've got a hell of a lot of these, and that's right. So you can see that they are right when they say avoid tick. It is costly. Now, every single frame I need to figure out where these are running. Now, there are a couple of things that I could do now completely to fix it, to keep this relatively smooth. Okay, so the first thing is you can change your tick within the class defaults. So you'll see that we have actor tick. You can turn it on, turn it off, and a couple of other settings. But the ones that I want to point out is we could give it a tick interval. So I could make this, if I made this 0.5, for example, the compile is taking time, and run it, you're going to see that we are back to the problem that we had before. It's getting jerked. So we've basically done the same thing that we did by using the delay. It's slightly cheaper under the hood. But we could even change it to 0.1. And this would have a very similar problem to if we just change this, but it wouldn't have the delay. Oops. I need to disconnect that. Yeah, because that's going to be causing problems, some double work. And now we see it's pretty smooth, but it's still a little bit jerky. And we're getting a bit of a fluctuation because, again, we're running at the same time with all of these. I think there might be some setting deviation, but anyway. Now, we also have some options. We can run the tick at a different point. Now, this is useful. For example, at the moment, we're running tick previous to physics being calculated. You do have an option that you can run it during physics being calculated. And if you've got a big physics calculation, this is quite nice because it will run in parallel and it's not going to cost you anything because it's doing it while the physics is running. Unfortunately, I don't have any physics doing things on here, so it's not going to actually save us any time, but just be aware that that exists. So if I kick that off, we might see a minute improvement. Be aware as well, if you need this to interact with physics, that's not necessarily going to be the best one. Yeah, we're still at 30. But let me talk about what is the real problem usually with tick. When I'm optimizing anything, the real time that I see tick being a problem is when you have a ton of actors. Because if I only had a couple of these, it would be absolutely fine. We would not have to worry about tick at all, because the amount of work every individual actor is doing is very, very small. So if I wanted to keep stuff running on tick, but not actually have it do anything, what I would do, there's a number of different ways that I could do this, but fundamentally what I want to do is I want to turn off any actors that I don't care about. So there are lots of ways to do this. You can check to see if the object is rendered and you can turn it on and off based on if it's rendered. You can use a manager in order to turn it on and off. But let me have a quick go at a very simple solution. Okay, so here we are back in the level. And what I've done is I've created a Canon manager. So what we're looking to do basically is to disable and enable tick depending on the distance from the player. Now, there are a lot of other ways that you could do this. One of the great ways to do it is to check if it's been recently rendered. So if it's not been recently rendered, you probably want to turn tick off. But for this example, that won't work very well because everything is being rendered. But I'm using a manager. And the reason I'm using a manager is because it's a separate actor. And this allows me to control how much work is going on. I can have 1 million actors inside the level, but with a manager, I can make sure that it only updates 1 or 2 at a time. So I will just show you how this works to start with. So I have the manager and change the distance to enable to 1000. And if I was to hit play, you'd see in the top left-hand corner that we have 385 of them are disabled, and we're running at about 50 frames per second, and 2 of them are enabled. Now, it's checking 10 at a time, but as I get close to them, you can see that they're now being enabled. So everything is disabled apart from anything that is close to me. As I move through them, you'll see that they turn on and they turn off. Now, this isn't perfect, and I can improve it by doing a couple of different things. First thing I can do is I can change the amount of cannons to check just to 1. I could speed it up if I check more cannons a turn. And I can turn debug off, and that will get rid of our the creation of those debug spears. Now you see we've got roughly about 60 frames per, 50, 60 frames per second. And they're turning on and turning off as we get close. Now we have 400 of these. So the chances are that you wouldn't need 400 of them. And the less of these that I have, the faster it's going to go through looking to turn them off and turn them back on again. But all we are enabling at any one time is what we need working. So again, if I was to change this to checking, and I'll check 10 cannons per second, and it's going to slow it down a bit. You'll find that the cannons turn on and off as we get closer to them. And I'll change the distance to be 4,000 and click play. That gives us considerably more running, and that's going to affect the frames per second. But you get the point. Let's have a quick look at what I've done in the Canon Manager. So the first thing I've done is I've delayed getting all of the actors. So the first thing I've done is got all the actors of the class, save them to an array, and grab the total. This is purely so that we can show how many are going on. Then on tick, what I'm doing is a loop for the check cannon, and I'm doing it the amount of times we've asked for the cannons to be, the amount of cannons we've asked to be checked per turn. So if I wanted to check 10 cannons, I can check 10. If I want to check 100. Now this is going to slow things down, obviously, and put more work on it. Now the check cannon task itself, we will get one of the cannons. If it is invalid index, we're going to go back to 0 so that we loop around, save the cannon. I'm saving, see if the tick is enabled, mostly for reporting, then checking the distance from that cannon to the player. Drawing the debug sphere, this turns on and off, increasing the index, and then depending on if the tick is enabled and if it's close to the player, I am enabling or disabling the tick. So you can see what this is doing, and this fixes what is the big problem that most people do with tick, and that is that they are leaving it on even if the actor is not needed and if there is not ticket. Now, there is loads of other ways that you can approach this. Like you can unload sections of levels, you can have other ways of sort of disabling. But this is a good way of doing it. What I would also say is there's more stuff that you can put on it. Tick isn't always the problem. Often you've got components which are ticket. Often you've got you have skeletal meshes which are updating the animation on frames. You can use the same method to go away and disable all of those things and re-enable them. And that you're going to find affects the output quite a lot. Okay, I hope that was useful. Just trying to clear up some of the stuff around tick.